First thing I'm going to do here, ninjas, is I'm going to go ahead here and find the limit as x approaches 1 from the right. Because whenever you see an absolute value sign, you want to make sure that you are approaching your limit value from both sides to make sure that you end up with the same result before saying it converges. So what I want to do here is choose a value slightly greater than 1, and I'm going to let x equal 2 in this case. And I want to say, okay, if I plug in x equals 2 into the expression x cubed minus 1, is the absolute value sign doing anything? Well, we know that 2 cubed, which is 8, and when you subtract 1, you get 7. When you take the absolute value of this, you are going from a positive to a positive. So it's almost like the absolute value is not even doing anything, right? Also, big thing you want to make sure you don't miss, make sure that when you're testing your value, that for this kind of an expression here, that you're not crossing over any sort of zero that could change the behavior and sign of that. But we're not having to worry about that here. And you tell me below why. So what I can say then with confidence is that when x is slightly greater than 1, then for the limit as x approaches 1 from the right, the expression x cubed minus 1, the absolute value sign didn't do anything. So I can just drop it, right? And now what's going to happen is, now you might be wondering, okay, well, we can now factor the top and bottom, right? Well, let's see. So we know that when you factor x cubed minus 1, you get this expression here. Because we did the work here to first figure out what the absolute value sign is doing, yes, now we can actually factor. Because if you're not careful with the absolute value sign, you can get the wrong expression completely. You might be getting a negative when you should be getting a positive, etc. And so what's nice about this is we no longer have a denominator. And now you can just plug in 1 directly, and you get 1 squared plus 1 plus 1, which will say that, okay, we get a value of 3 when we approach x from the right. So now we want to figure out, okay, for the left-hand limit, am I going to get the same thing? So now I'm going to see, okay, for this limit expression here, when you approach 1 from the left this time of x cubed minus 1, taking its absolute value all over x minus 1, choose a value slightly less than 1 here. And I'm going to say, okay, well, I don't really have any zeros that I have to worry about between 0 and 1 for r, right, in the real domain. So I'm just going to choose 1/2. Let's just let x equal 1/2. So what's happening with this expression here? 1/2 cubed minus 1, taking the absolute value sign. Is the sign changing? And the answer is going to be yes, because this right here is going to be less than 1, right? And so we can say in this case that, okay, we're going from a negative to a positive. But then for the denominator, you're going to have something that's going to be 1/2 minus 1, and that's also negative. So in this case, for the left-hand limit, where you are approaching 1 from the left, we can't just drop the absolute value sign. This is where many of you mess up. The absolute value sign was changing this expression's sign. So why don't we just put a negative in front and solve this like we normally would any typical limit? Because now when you factor the top like we did before, you're going to get negative x minus 1 times x squared plus x plus 1. And just like before, when we approach the limit from the other side, we can ninja chop these two. And you notice now that we've got this here, whereas for the right-hand limit, we didn't. Got to be careful with these absolute values, guys. Now I'm going to go ahead and plug in 1. So you're going to get a negative in front of 1 squared. Oops. Plus 1 plus 1. And this is going to give you a negative 3 as that answer. And so did we get that before? Well, let's go back up. Drum roll, please. We got our answer as positive 3. So depending on what side you approach this limit, you either got a 3 or a -3, which tells us the limit actually doesn't exist.